In this video, we are discussing Cartesian product pattern example. So here we shall go for one implementation of this concept. In the previous video, we have discussed what is the Cartesian product design pattern. So now let us go for the implementation through one example. So what is the assignment? Assignment is something like this. So in this example, we have designed to find the cross product of same data file, and we are providing the tags.xml file to find the cross product. So here we will be using only one XML, that is the tags.xml, and we can use any other file, but as this process is costly, so we are providing the XML which is the smallest in size. So now let us go for one practical implementation of this concept to get the idea in a better way.
Under the category of join pattern, design pattern, we are going to discuss the implementation of Cartesian product example, and we shall handle this tags.xml. So that will be our input XML file under the folder /input/tags. So this is a one XML file will be going, and we shall go for the Cartesian product operation. So let me show you the current content of this tags.xml. What are the tags are there and residing under this tags inputs tags. So let me go for this tags.xml. So under the tags, we are having multiple rows, and here I'm highlighting the respective attribute under the row tags. So ID, tag name, count, expert, post ID, and then we keep post ID. So these are the respective multiple rows are there in this tags.xml. Let me jump to our Java file. It is having only one Java file, that is a Cartesian product MR task. So Cartesian product MR task, we are having multiple inner classes under this class. The first inner class is Cartesian input format, which extends the file input format. So here we are defining some public static final string variables, and we are having the variables like your left input format is equal to cart.left.input format, and all this right hand side whatever we're writing, they are available under the Hadoop API. So left input format, cart.left.input format. Then we shall be having our left input path, so another public static final string. So left input path, that will be initialized with cart.left.path. Right input format, right input path. So all these public static final strings will be initialized here. So we have initialized them all the four. Then here we are going to have one, that is a set left input, one method we are defining, and here we are writing only two, that is a jobconf.set left input format, which will be set with input format.get canonical name, and left input path will be set with input path. So that is the two lines we have written under this set left input. These two lines we have written, I'm just marking so that you can understand. And now we are having this set right input, another method we have written under this class. So here we are having two lines, jobconf.set right input format.get canonical name, and right input path will be initialized with this input path. Next, we are going to overwrite one method, that is the get splits. We are having the method get splits. We are overwriting that one. It returns input split array. It returns input split array. So here we are defining this input split, two objects, left splits and right splits. So here you can see that get input splits conf.get left input format, and the left input path, right input format, right input path, and num splits and num splits. So that we have passed as input argument. We have just mentioned that one there. Next one, we're going to have the size of final split, that is the left side into right side. That is obvious, because in case of Cartesian product, we are going to have all the possible combinations of left schema and right schema. So the length will be multiplied, as we have mentioned here. There is a left splits dot length into right splits dot length, and number of columns, that is a number of attributes, will be added in the final result. But the number of rows will be multiplied in the final result. That is a feature of this Cartesian product. So here we are executing int I is equal to 0, input split left item will be searching on this left splits. So input split right item will be searching on the right splits. So for I is equal to 0, we are executing these two nested for loops. So final split I is equal to new composite input split 2. So we are having we're going to have this left item and right item. We're going to add here using these lines, and then I plus plus or plus plus I. So in this way we shall go on adding. The final split will be populated with this left item and with this right item, and final split I will be at first instantiated with this new composite input split 2. So in this way the for loop has got executed. I'm marking so that you can understand it better. I plus plus will be done for each and every for loop execution, and we are writing one log info only to for the final check that final splits to process is this. So that will be printed when we shall execute our code, and return final split. Everything has been kept in the try catch block for the exception handling. This final split dot length will be printed when we shall show you the output there, and that value will be returned. Now we are going for another method, that is the get record reader, which will return the Cartesian record reader object, and here it will be having the composite input split, converting the split, there is a typecasting we are doing, and the job conf and the reporter. So these three parameters will be returned against this particular object we have created under the class Cartesian record reader. So I'm just marking that one. You can see that from where the values came. So they came from the parameters, input parameters. Now the next method is get input split. So in case of get input split, we are defining one file input format object, that is the input format, and this particular has got instantiated, this object has got instantiated using reflection units dot new instance class dot for name, that is the input format class, comma job conf. So against this particular class the new instance has been created, and the job conf which is passed as the input parameter, so they have been mentioned there. Input format dot set input paths, there is a job configuration, there is a job conf, and input path. So input path is there, that has been passed as input string. When you will be calling these functions, you can see the parameters will be passed, and then we are returning the input format dot get splits, job conf, and number of splits. So in this way the methods are ready. We're having another inner class, that is our Cartesian record reader, which implements the interface record reader, and under this record reader we are having one method. The methods are to be instantiated. We're defining one private record reader object initialized with null, and left record reader and the right record reader initialized with null. Store configuration to recreate the right record reader. So file input format, under that we have created one object, that is a right I input format. Then we are having the job conf object, there is a right conf, input split object, there is a right input split is. So reporter object, that is a right reporter. So these are the store configuration to recreate the right record reader. We are going for the helper variables like left key, left value, right key, right value, and we are initializing the next left with true and done with false. So these are the boolean variables are there, they are known as the helper variables. So all this we have defined under this inner class. Actually this is one you can find that there is a Cartesian record reader is one inner class. So this is a constructor under this class, this is a constructor. So this constructor has got multiple arguments, and those arguments are being passed to initialize this right conf, right is, and right reporter. So these variables are getting updated by the input parameters passed to this right record reader constructor. You can find that I'm just marking so that you can feel that from where the values are coming. And next one is the right reporter, which will be initialized with this reporter, which we passed as the input argument to this constructor. Now we have kept the block within the try catch. File input format, left file input format, so left FIF, we're initializing that one, passing the that is a reflection utils dot new instance. So it is class.for name, there is a conf.get Cartesian input format dot left input format and then conf. So in this way we are just initializing some variables, and all these variables will be required for the left record reader. To create the left record reader we are just creating all this. So left record reader is equal to left FIF get record reader split dot get 0. That means for the we are going to split that one. The first argument we are going for splitting conf, and that one, that is a reporter. These are the passing arguments. Now going for the right input format. We are going for the right input format. So here we are having this one. The class.for name is having the conf.get Cartesian input format, right input format, and conf. So same thing which we did in our left FIF. Here also we are doing the same. Then we are going for this right record reader has been initialized accordingly. So everything has been kept in the try catch block. We are going to create the key value pairs for parsing. So left key will be initialized with this, left value will be initialized accordingly, create key and create value. Then right key and right value will be also initialized with the same way as I have marked here. Now here we are overwriting few methods, that is a public text create key which returns a new text object, that is a create key we will be referring there. Next one is a create value which will be returning a new text object. We are having this public long get pause throws IO exception which returns left reader dot get pause, so that will be returned there. Overriding the method next, within which we are having this text key and the text value. So now here we are doing this next method body. So if the left next is present, that means not null, and not left record reader dot next left key and left value, then done is equal to true break. That means it will come out from the loop, and that will be done for the next key value pair. So if the left record reader dot next is not existing, then done is equal to true and break. Else key dot set left value dot to string, so it will be converted, the value to be converted to the string. So key will be set, and next left is equal to done is equal to false. So in this way you have just written this code. So reset the right record reader. We are going for the next line, that is a reset the right record reader. You can find each and every line has been associated with the respective comments. Right record reader has been initialized with this right input format dot get record reader, and record parameters have been passed. If right record reader dot next is existing, these are the parameters. I'm showing that one. Just see, these are the parameters are there. We have passed that one. So if right record reader dot next right key and right value, then we are having that if block there. So value dot set there is a right record reader dot next right key and right value. If it is not null, then value dot set right value dot to string, converting it to the string and assigning to the value. Else next left is equal to true. So completing the right, go to the left again. So while next left is not equal to true. So in this way the things will be done, and return not of done. That means if done is equal to true, then it will be returning false. If done is equal to false, then it will be returning true. So that is the boolean, that is the output will be there. So the function will have some output, that means some return argument. Now overriding the close method, we are not doing anything, just we are closing the respective left record reader and right record reader. We are closing here. So these two lines we have written under the close overwritten method. Now we are having this get process. So return left record reader dot get process. So that is our get process. We have also overwritten the respective method. Now let me go for the mapper. Let me go for the mapper class. So now here Cartesian pattern mapper extends the MapReduce base and implements the interface mapper. You know that whenever you are going to implement the mapper interface, we are supposed to write you must be writing the map method for that, because the map method is undefined in mapper interface. So here this is the case. Now we'll be going for private text. There is output key is equal to new text. We are defining one new text, and then the map function we have written. After defining this output key, we have written the map function. Within the map function, we have written that key dot toString dot equals value dot toString. If it is not true, when both are not equal, then you are defining two string arrays. One is a left OK, and another one is a right talk, that is a TOK. You can find that. So they are getting initialized with this key to string. So left to key. Here // s is actually the regular expression, that is a blank space actually. Actually the blank space in regular expression you express it as /s, but we are writing that one within double quotes, so we are writing that one // s. So left to key and right to key you can find by defining two hash sets objects. There is a left set and right set. These are the two hash set objects we have defined, and instantiating arrays to as list dot left to key and right to key. So int same word count is equal to 0. String builder object we have defined as words is equal to new string builder. We are executing one for loop, that means a string element which will be searching, iterating on this left set. If right set dot contains element, if the element is also available on the right set, add element from right set. So words dot append element plus comma, so comma will be the delimiter here, and the same word count will be increased by 1. If the same word count is greater than 2, if it is so, and after executing this one, if same word count is greater than 2, then output key dot set words plus 1 tab, and then key will be set to the key, and output dot collect will be the output key and the respective value. So I'm just marking them so that you can understand that output key output dot collect is equal to output key comma value. Now let me come to the main function. Within the main function we have defined one long start time, which is the current time in millisecond, the current time millis, that is a respective class. Under that we have instantiated, that is a method we have called, and return argument has been put on this long start time, and then it is a long type. So job configuration config is equal to new job configuration Cartesian product. We define one job with the name, and here we require two arguments to be passed. So usage is given there, Cartesian product mr task, that is a class name, input folder and output folder. The input folder and output folder is to be given. If the length count is not 2, then error message will be shown showing this usage. We're defining the set jar by class, set mapper class. We're defining each one of them after discussing this set jar by class. There is a jar class name, set mapper class, inner class we defined already. There is a Cartesian pattern mapper dot class, and here it is a map only job, so no reducer. Now going to initialize this set input format, that is a Cartesian input format dot class, set left input, that is a config text input format dot class, and argument 0, that is the first argument, and set right input, so that will be also taken from the argument 0, that is the first argument, that is the input path. Text output format set output path config, and new path args1, that means that is the second argument, whatever will be passing, that is a there is a output file path that will be there. Config.set output key class and config.set output value class, so all of them will be text class. Job will be made running, so job client dot run job config, and if the job is not complete, that means not is there, complement is there, then you shall wait for 1 second sleep, thread dot sleep 1000 milliseconds. Finish time will be calculated, finish time, so define one long finish time, system dot current time millis, there is a respective value will be there. So now we'll be just going for the difference of finish time minus start time to get the total time in millisecond, and if the job is successful, return will be 0, otherwise return will be 2. So finish time and start time will be the total time taken in milliseconds. So that will be calculated here. So now we shall go for the jar file creation. So package, right button click, package name, right button click, then export, then jar file will be created giving the jar file name and the path. So that we did so many times in the earlier programs also. So same process will be executed, but we have already created the jar file, so we can skip this path here, skip this part here. So now you can directly go to the console to show you that how to run this program and how the outputs would be coming. So that will be a better idea for us. So here the command we have listed here. There is a Hadoop jar, then the respective jar file folder and the jar file name. Then we'll be having, let me come down, yes, let me having this one as the there is a package name, next one is the class name, then we are having the input path, that is a /input/tags. there is a path where the XML file is residing and the output path is there. If I execute my command, you can find that we shall be executing this command now. So see, the time in millisecond is 35374. We wrote that time. There is a finish time and a start time. So 35374 is the time in millisecond. Now we shall show you the output, that how the Cartesian product has been done. So the command is hdfs dfs, then we shall go for -cat, then we shall go for blank space will be there, blank space, and then output, and then we shall go for there's a part star, PRT start. Okay, so now if I press enter, you know that in case of Cartesian product between two data sources, the number of columns will be added and the number of rows for two data sources will be multiplied in the resultant table. So huge number of records are there. You can find that it is a big output. The part is containing so big output, you can find so big, so long, huge outputs are there because the number of rows are getting multiplied. It is producing all possible feasible combinations of two record sources. So that's why it is a big output we are getting. You see, for the couple of multiple number of seconds, it is just scrolling up and the outputs are getting printed. So I hope that you got the idea how to write the code, how to execute the commands, how to get the outputs, how to see the outputs, and everything we have done step by step. So I think now you are confident to work on this Cartesian product example falling under this join pattern. You can do it at your end also. Pause the video, type the code, and get it done. There's a long output we are finding. All possible combinations of two record sources, number of rows will be multiplied, number of columns will be added up in the final outcome. That is the basic logic behind the Cartesian product. So Cartesian product will be used as when required, not always, because it will occupy huge memory. So that's why you always try to avoid it. So this is a huge output we have got. You can find that. I'm just putting that output on the screen. Let me see the file size is, how is the file size here. So let me go for the output folder. Let me go for the output folder. The input file was here 106.26 KB, the tags.xml. Let me go for the output folder. See, for the output folder, the file size is 296.15 MB. So you see, it has got so much big in size compared to the input file size. Input file was in KB, it is now in MB. So let me see the output here. Let me delete this output folder. Thanks for watching.